Hello, we're going to talk about industrial networking. I have with me Bob Trask, North American representative, EtherCAT Technology Group. Trask worked at Beckhoff Automation as an engineer, software product manager, and systems architect for 20 years. Trask holds a Bachelor of Science in Electrical Engineering from North Carolina State University and has 30 years experience with automation, motion control, and communication systems. He's a registered professional engineer. I'm Mark T. Hosky, Control Engineering Editor and Content Manager since 1994. Bob, welcome and thanks for today's discussion. Let's start broadly to begin and then get more specific about EtherCAT and EtherCAT Technology Group. First, what automation controls and instrumentation trends are industrial network organizations addressing today?
Hi, Mark. Yeah, I'm going to tell a quick little story. I bumped into a friend of mine very recently, and she came to me. She's a mechanical engineer from Iowa State, and she was in a meeting where they were planning a pretty significant project going on that involved a lot of motors and sensors, actuators, safety, a bunch of things. And she said, Bob, the consensus was just use Ethernet. And I knew that wasn't a complete enough story, but I didn't have enough ammunition to say, well, that doesn't tell a lot. But anyway, the trends we're seeing in industrial automation systems is the use of physical layer Ethernet. And unfortunately, Ethernet gets tossed around in many ways, and it lumps together things that shouldn't always be assumed. But Ethernet really is a very, low-level physical way of transmitting information. Clearly, though, Ethernet at all levels of factory automation is the way to go. Specifically for me, I work a lot with motion systems. I grew up in motion control, and even for years, I fought this and I was completely wrong. And that is the notion of centralized motion control. And by that, I mean you have a device, a controller, a PC, a PLC, a PAC that generates all the motion commands, generates the trajectories, and then spoon feeds out velocities, positions, maybe current to the drives. And that actually becomes a very efficient, clean way to do motion control. And I don't have a lot of handshaking. I don't have a lot of, holding things. And is this done? Okay, that's done. We can do this. When I do it all in one spot, a lot of things become easier. And even more specific than that, the what's called the cyclic synchronous modes, which start off with position and then velocity and then current or torque. And most of the people that I work with have just settled on CSV, cyclic synchronous velocity. And even you can be in position mode, and still it's easier and smoother and cleaner to spoon feed velocities to all the devices. And it doesn't have to be a super fancy servo. It can be a stepper or a VFD or anything. And if you can do this, then you can do any of the lesser systems. Another strong trend is safety, what I call soft safety. And by soft, I don't necessarily mean software, although that is certainly a component, but not hardwired, dual relays with auxiliary contacts to say, okay, here's the status of this relay, and do relays for every single device. And clearly the trend is to have an integrated safety system where safety is integrated into the drive or whatever device you're working with. And along with that is embedded in the drive different, not just necessarily moving power, which is called safe torque off, STO, but there are different safe speed, safe stopping, safe ramping, different safety modes you can use with that device, because it's not always the best thing just to cut power from the motion system. And the trend these days is to be able to recover from things. If I hit an e-stop, okay, we stop the process, but just to have everything free rolling, which is how we've done it for a long time, is it's old school, and they're by far most reputable manufacturers of motion systems, and really any automation systems have or certainly in the process of integrating these things. Robotics for one. The PCs, not knocking PLCs, but a PC-based platform makes what I call north of the control, north of the field devices, much easier to deal with. There are many ubiquitous, low-cost mechanisms to transfer information from the field level on out. And EtherCAT really is a device level protocol. We completely recognize the need to shuffle information and flag events and do different things with higher levels. But the focus of EtherCAT is really the device level, providing the appropriate mechanisms to communicate outward. Openness, internet technologies, the ability to use the quote unquote internet technologies, which is when people say Ethernet, they often mean the whole, IT world, but there are many decisions and things that have to be made about that. But it's inclusive of mechanisms like MQTT, you're hearing more about, OPC UA, which I personally am a huge fan of and very involved with that organization. And frankly, EtherCAT is considered an open platform, not open source, but an open platform where anyone can get in and both use it and design something that will work with the general community. Cybersecurity is an issue. We are the EtherCAT Technology Group is not a fan of IP routed mechanisms. We feel that at the device level, they need to be shielded. You need to be able to put systems in. I was talking with James earlier, and recently I worked with a press manufacturer, and they would build loaders and unloaders, but I'll focus on the loaders. And they wanted the loader to be exactly the same for every press. So, the same drive, the same sensors, the same mechanism, the same encoders, didn't have to worry about addressing, and they could replicate this loader for every device without having to do anything to integrate it. And I get a little concerned, and cybersecurity is such a huge deal, and we're hearing more and more about it now. And many complications and aspects of cybersecurity really completely disappear with EtherCAT. There is no guide to EtherCAT cybersecurity. It doesn't exist because there's no reasons to, and we'll talk a little bit more about that in a few minutes. And an up-and-comer that has been around for a while and is really just now starting to become more mainstream is the concept of predictive maintenance, not preventive maintenance, but predictive. And it's more complicated, often involves machine learning, often involves AI, if you will. And you often will have to look at a system, work over time, and make determinations about how it's behaving and what measurements you do have. And then if anything gets out of sync with that, that trends in a direction that it hasn't before, that can be and often is a sign that, okay, I need to spend some time looking at this system. I need maybe the motor temperature is too high, maybe a vibration component wasn't there before, maybe it's drawing more current than it has been historically in a given process. And the point is to be able to flag systems that before they break, before they say, okay, I'm done. And to start to flag these things before they become an issue and come up with a reasonable method, a reasonable way of addressing that before it becomes an issue.
Where is EtherCAT being applied, and what kind of applications and why?
EtherCAT's very popular in really super high-end motion systems, synchronized, from synchronized processes to robotics. There are hundreds of drive manufacturers and servo, stepper, VFDs, and there's several advantages. One is the way EtherCAT works, and another is a very clean way of sharing a system clock. And the concept of distributed clocks is really another thing that's nothing new. It's just applied here in a very efficient way, where a whole system can share a system clock that is within tens of nanoseconds of this clock, and you can get a pulse and say, okay, everything in the system update at this point in time, and all kinds of tuning, all kinds of complications disappear when the whole system is, click, update now, rewrite now. And then you allow time for the shuffling. Next cycle, click at this point, do this now. And this is the reason EtherCAT's so strong in motion control arenas. Now, the thing that is interesting is most people will use EtherCAT not because of this. I don't need the performance. I don't need, and by the way, all this is built in. Doesn't require any special hardware. Doesn't require anything other than for it to be enabled. Now, most people use EtherCAT because there's this very interesting flexibility in topology, and you don't have to. It's non-switched, and even if other field buses that I've been familiar with, even if they are line-to-line kind of topology, they still have an internal switch. And I'm talking Ethernet technologies, not the device nets and CAN opens. But to be able to drop, okay, I need a new encoder here, I need a new sensor, or I need a new actuator. To plan for that is just to find another EtherCAT port and plug it in. It sounds too good to be true, but it just doesn't matter. There's no tuning, there's no addressing, and you have this complete flexibility in topology, which is one of the reasons EtherCAT's becoming so popular in more spread out applications in intralogistics and theme parks and warehousing, because I can add a node, I can add a device without having to have any supporting hardware to it other than the cable. EtherCAT has a reputation with OEMs of being much simpler to integrate. They build the machine, they take it out, and they put it in, and it doesn't take multiple meetings with the factory IT guys, and I need to have switches housed and powered, and all that just disappears. So it has a nice reputation amongst OEMs and end users for being, much simpler to integrate. There are three interesting areas of, I don't know if domination is the right word, but certainly just massive EtherCAT use. There are there's three ongoing these huge, massive ground-based telescopes that are in the process of working. Two of them happen to be headquartered up the road from where I am, and I've got involved with these. And actually, a lot of work was done through the past few years when it was harder to travel around, and they were just up the road. But anyway, these are massive telescopes. And EtherCAT got its start with the concept of adaptive, making finite changes to the mirrors to get rid of the twinkle, adaptive optics. And people who are using these said, well, why don't we just use it for all the other stuff? You know, the rotating mechanisms, the temperature control, the humidity control, because there's so many things about these devices that have, time matters, the synchronization matters. The time on these things is very critical. And if you're out because a drive is not working, then some researcher lost his time on the telescope, and that always has an inquiry in issues. But EtherCAT's become quite popular in these massive ground-based telescopes. Entertainment is a really interesting thing because entertainment involves safety. We never want EtherCAT to be on the front page. Hey, EtherCAT had an issue and something bad happened. Robustness. In other words, many of these things are built up, taken down, moved, and then built up again. And when you're going to have issues, you're going to have cables that don't get connected right and things that just don't work and things that don't get powered up. And to be able to locate, not there's a problem somewhere over there, but here is the problem. Here is the exact point of the problem. Send a guy up there. Oh, the cable's not attached right. And by far, most problems are really very simple. There are cables and connectors that just don't get attached the same way twice. And EtherCAT's become very popular in the entertainment industry. It really is a pressure. The show must go on. To have it, there's 15,000 people showing up for this event in an hour. You do not want to be the guy that's holding that up. And it's been fun to work with people on this. Another one is semiconductor, which again, safety, huge deal. The semiconductor industry, these horrible, terrible chemicals, and you have to be very, very careful about that. And then another thing, the semiconductor industry, once you start something, it's very, very expensive to stop it. You can't just stop it. You have to have a way of dealing with single failures. And there's a whole concept of EtherCAT with redundancy, media redundancy, because again, most problems are cables and connectors. And if you can get around that and still locate the problem without affecting the process, huge deal. And we are very involved with the semiconductor industry, the semiconductor working group, the technical working group, the TWIG as people call it. And there are 14 initiatives, from chillers to power supplies to vacuum systems, and they all have their own concerns. And these are very, very complicated things. Sometimes they're more complicated than the EtherCAT protocol itself. But the point is, for the semiconductor industry, they're going to buy a vacuum system from somebody and another vendor, and they want them to operate the same within the EtherCAT domain. And that's really coming to fruition as we speak. We're 11 ratified, certified additions to EtherCAT out of the 14. And what's interesting to note is, and I can't specify any one company because these are areas that are really on the cutting edge of things, and they don't necessarily want others to know how they're doing things. But this includes space hardware manufacturing, because getting things up off the ground, wait. How much does it weigh? How much does it weigh? How much does it weigh? And by the way, it better not break. So you have this balance between how much something weighs and what kind of safety factors associated. So the cleaner the manufacturing, the better you can do that. The tolerances, save weight, while at the same time keeping your, a safety factor high. And EtherCAT is interestingly involved in both aerospace and space applications from that standpoint. And another thing we're seeing is with medical robotics and humanoid robotics. Again, they're super high-end stuff, and there's a lot of cool things coming down the road with regard to robotics in general. They're getting away from proprietary protocols, and the CAN protocol has been very popular in those, and that is receding over time.
Well, thank you, Bob Trask, North American representative, EtherCAT Technology Group, for the discussion, the perspectives, and the insights. I'm Mark T. Hosky, Control Engineering Content Manager. Thanks for joining us.